Morning, brother.
Hey, Yuko. How's it going?
Good. My
Yeah.
mom is on the phone. She's having a hard time, so I'll be talking. I'll be listening to her while I work with you guys through. I did the entire thing on paper, so it should help us move faster. And also, I got a new trick from a tutor that will be really helpful on the exam. But please remind me to let you guys know about it after as we go through.
Okay.
Okay.
Sounds good. I'll remind you. Okay, so next week is just a review for the exam. We
Yeah.
didn't do very well on our uh, survey thing. It was pretty much denied. So we have to come up with a new one. So that's fantastic. But let's just get this review done. So I'm looking at number 2 right now. We need to figure out what what calculation we need
Yeah.
to perform.
One, one.
Okay, so we're doing a startup business, educational level of people who manage to accept the fucking athletes from Korea. If education level measures in the country from hypothesis test would be most appropriate for this. Um,
This is a cast square.
That is what I'm also
Hey,
thinking.
man, I was on a someone was asking. Yeah, I'll be back, guys.
okay.
I was thinking of it the chi-square test because um, what might happen in Korea and what might happen in United States are two different things. I don't know whether that one data will be independent of will be dependent on the others. So
Okay. I'll agree with that. So number 3. Um, for the number of employees who 40 years old, younger, over 40 years old. Well, each one of both age groups were treated equally. Yeah, how many of these do we have to do? A lot. Fantastic. Independent sample test. Versus paired data.
This one is not going to be a test for caution.
All right.
Perhaps. I'm having a hard time even finding.
Which one are you guys on?
3.
Question number 3.
Okay, so did you guys settle that this was a chi-square?
On 2, yes.
Okay.
Yes.
And then number 3, let me see a human. Oh, there we go. All right. So, okay. So this might help for us to go through the tip that I got from my tutor. Do you guys have a pencil that I can explain it real quick?
Sure.
So, so there are two type of statistic group that we'll be looking at, right? Well, that we've looked at. So one sample z-test, one sample t-test, pair samples t-test, independent samples t-test, ANOVA. Those 5 are quantitative.
Okay.
Okay. And then tests of 1 proportion, tests of 2 proportions, chi-square tests of independence, those are categorical. And then, let me know if I'm going too fast. So here are the 2 important things to look out for. If it is quantitative, these are the words that you will see coming out. You will hear about the mean, the average, the amount, or the value. If you hear any of these words jump out at you, just know almost immediately that question will be a quantitative question. And then you will look into one of that quantitative group to know what tests to use. If you hear words like preference, proportions, category, percentage, brand, kind of like a brand name, or a word or a quote that is in quotation or differs, those are categorical. Once you find those words, you will go straight to the category section, which is test of 1 proportion, test of 2 proportions, or chi-square. So when he taught me that yesterday, I went and did the homework with it. I got 100 on it. So the second I see things, I see one of those words that belong to category or quantitative, I start thinking, is it a 1 sample, like a 1 group, or is it 2 group and all that? And that can kind of help in like deciphering what test to use on it. Does that make sense at all?
Yeah.
Yeah, that'd be really helpful.
Okay. And then question number 3, and I will show how this apply to question number 3. So a human resources manager reported data from a recent involuntary reduction of force at a company. You are an attorney and want to determine if age discrimination was a factor. It is illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups, 40 years old or younger and 40 years old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. So can you guys tell which group that this will be in already? So there's 40-year-old, younger, and over. That's a category right there. And
Yes.
and if it's categorical, then we move down to the category section, which is just three type of tests: one proportion, two proportion, or chi-square, where there's two different groups that will be there. So we do tests of two proportion. That's number 3 answer.
Okay.
So you see how it's weird when he taught me it, but once you practice it for a little bit, it kind of get easier once you start practicing it.
Yeah. Okay. Yeah, I can see how that's categorical. The test of two proportions. Great.
45 question? Holy cow! I didn't notice that.
Yeah, I know. If you need to leave and come back, that's fine.
That's okay. I did most of it with him, and all the one I did with him are correct. I mean, I can read the answers as we run through, but I think it would be good to just go over it since it's kind of a review, because I'm thinking this next exam might be a bit of busy work. So
Yeah.
Number 4.
I've got a visitor real quick, so I need to be right back, okay?
Okay, that's okay.
Okay.
So number 4 says a survey was conducted by a group of state lotteries. A random sample of 2406 adults completed the survey. A total of 248 were classified as heavy players. You notice the quotation there?
Classified. Yeah.
So can you tell which group that it will be in?
This is going to be qualitative. So it will be under categorical or a difference. That's what I'm thinking. Yeah.
Let's see. Let's continue reading and see. Of these 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population. Yeah. So on that one, I have. So let's see this.
Okay, where you at? What was number 4?
Number 4.
Yeah.
All right, let's see here. So, oh, wait, we're on number 3. Sorry.
You're on 3? We did.
We did number 3. We're moving to number 4.
Oh, wait, we did number 3. Oh, geez. Sorry. I am falling behind like crazy. Wait, what did we get for number 3?
You said it was test of two proportions.
Sorry, I read the wrong answer. Number 2 is test of two proportion, and because I printed it out on a paper, so some of the question laps over and I mistakenly read that. Number 2 is test of two proportion, and number 3 is test of one proportion. My bad.
Okay. So how did your
these questions are throwing me off. In an article, it's not correct. Okay, so number 2X got. Oh, I see what's throwing me off. So the numbers on the reviews are different than the numbers here. So that's what's messing with me. So that's good. So number 3 here is number 2 on the how do you call it? On the review.
Okay.
Does that make sense? That's what I was throwing me. So I will go slowly now and recognize the question that is asking. So number 2, a human resource. That will be number 3, test of two proportion. We got that correct. Number 4, in this case here, a survey was conducted. That will be number 3. This is test of one proportion. So number 4 is test of one proportion.
Okay.
All right, and we can go through it slowly for you guys to see. So there's a quotation over there, heavy user. So that's categorical. And since it's the same group that they're using to determine, we're not dealing with two different groups, it'll be test of one proportion. That's how I got that. And I'll try to go slower because I just realized that the questions here are slightly numbered different than the ones on the review. So I'll try to not go directly from the review. And I'll stop talking because I'm talking too much. So for number 5, a student project compared the effectiveness of two different combination locks. One of the locks turned clockwise first and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination of each lock and asked to open the locks. The time it took them to open each lock was recorded. So if it's talking about time there, then a value should kind of stick out. They want to determine if one of the locks is easier to open. On this one, so there are 25 students that participate in this study. They want to determine if one of the locks is easier to open, but because they mentioned there the time that it takes, so because of time, that's kind of a value. So they put this question in quantitative. Does that make sense? Because you're counting the time that it takes, or you want to know the difference in mean or average, or there's some value attached to that. So this will be a one sample t-test.
T-test, huh?
Okay,
because so I see where you got the quantitative. Where did you get the one sample t-test?
Okay, the one sample t-test. One sample t-test, if quantitative, the standard deviation is always unknown. Okay. And it is from the same group. So this is dependent. Does that make sense? The same 25 students are on lock with one lock. There will be the same student that will unlock the other one. So it is dependent. It's a dependent, how do you call it? A dependent, so they're independent and dependent, right? And independent, when you choose, if it is a dependent, those you choose from one group will tell you something about those you choose from another group, right?
Mm-hmm. Yes.
Yeah. And since it's just one group, it's just one sample that we need, because the same sample will be doing two tasks. So that makes it one sample t-test.
Okay.
That makes sense at all? Sometimes I understand it and explaining it.
So on a one sample z-test,
the standard
deviation will be given.
Yeah.
Okay.
Or you have to calculate. They will give you something for you to calculate it, or you have to calculate it, or it will be given to you.
Okay.
Okay.
Does that make sense at all? And sorry if I'm like going all over the place.
No, you're good.
Okay.
Glad you met with the tutor. That's great. It's helping us all out.
Okay. Question
number 6.
Let's see. A bank employs. Okay. A bank employs 2 appraisers when approving a borrower for mortgages. It is imperative that the appraiser's value. You notice the value?
Yeah.
Okay. So that put us in quantitative already. So as we're going through, we're taking quantitative and what kind of tests we use. So the value, where is it? Where was that? The appraisers value the same types of property consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers have recently valued. which confidence interval would be most appropriate for this? This same pattern that we've been using applies here, except we'll be doing interval now instead of, you know, test. Does that make sense?
Yeah.
So in this case, it's quantitative. So we're going over to whether or not it's one sample Z-test, one sample T-test, pair samples T-test, independent sample T-test, or ANOVA. We won't do ANOVA because that's more than two. So it's between pair samples T-test and independent sample T-test. And the reason I said those two is it's not one sample. We have two different guys that they are running against. So since the same, how do you call it? The 6 properties that they will use, both appraisers have to do it. It is a pair sample T-test because the 6 sample will work for both of them, but they're checking both of them separately. Does that make sense?
Yeah.
Yes.
So it's paired because the same property that let's say appraiser A does, it's the same property that appraiser B will have to do as well. So it is paired because they're trying to know the difference between those two.
Okay. I think that makes sense.
Well, I probably shouldn't have said test, a confidence interval.
Yeah.
Man, statistic is like English is already hard, let alone statistic itself.
Yeah, you're pretty brave, man, for doing it.
Let's see.
So this one is a paired sample T-test. Sample T confidence interval.
Yeah, number 6 is pair samples T confidence interval.
Yeah. Okay.
And then number 7, in the Wall Street Journal article, unsatisfaction with career paths, the percentage of psychology majors. So you notice the percentage? So they mentioned percentage, so that automatically tells us its category.
Yeah.
As a reporting, they were satisfied with their career path was reported. The same, sorry. The same data was also reported for accounting majors. You decide to construct it on a 5% confidence interval to see if the observed difference. That's like the third clue so far. The observed difference is significant. Okay, so going back, he said there's a quotation there, satisfied. So that put us in category, right?
Mm-hmm.
And then we're dealing with 2 different samples because, well, independent, because if you pick accounting major, it doesn't necessarily tell you, you know, psychology major. It won't tell you anything about psychology major, right?
You're right.
So
They were satisfied. Same data was reported for accounting majors. Psychology and accounting. So it's so it'd be a confidence interval for 2 proportions, right?
let me see my test. 1 second. Yeah, two proportion confidence interval. You're right.
Yeah, I got it right. Sweet. Cool. It's really helping out a lot, Oku. Thank you.
You're welcome. It's thanks to to my tutor. I had the same guy for tutoring when I did on Math 110, and all we talked about was soccer. You can tell the grade that I got from that class. so this time I learned my lesson. When I get there, it's like, let's get straight to business. Let's not talk about soccer until we're done.
Nice.
Oh, awesome. What number are we we're on double stuffed Oreo, right?
Yep, number 8.
Okay. Double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. Oh, and a word of caution, this one threw me for a loop because they throw a lot of things in just to get you interested in it, but they're all useless information. So when I first answered this one, I got it wrong, and my tutor looked at me and said, pay close attention to what they're trying to do. So I will go through and then you'll kind of see what I mean.
Okay.
Double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that is a true assertion by the company who makes them. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount found in other regular Oreos. Which confidence interval will be most appropriate for this study?
My first thought is that it's quantitative.
Okay.
I don't know my confidence intervals very well.
Okay. So you are right. It is quantitative. The only thing that would throw us off there is the regular Oreo cookies. So once we ignore that, we know it's a one sample confidence interval. Does that make sense?
Yeah, because we're ignoring the regular.
Yeah, and we're only doing double stuff Oreo. So it's one sample confidence interval.
One sample. Which one did you say, or did you ask me?
One sample confidence interval. And it's easy to think one proportion. It will only be proportion if it was categorical, but this is clearly quantitative, as you mentioned. So
Yeah.
we'll do one sample
Right.
sample.
No, I don't know if it's a Z or a T.
It's a T because the standard deviation is unknown.
Okay, so that's what it comes down to.
Mm-hmm.
Knowing the standard deviation, which they don't give us, right?
No. If they had given some kind of standard deviation or giving us stuff for us to calculate the standard deviation, then we're going to lean towards Z confidence interval.
Okay.
Is Bartholomew there? Bartholomew, is that making sense? I know I'm talking too much this morning. I woke up hoping to be calm, but with the phone call, I just got up. I'm just all rowdy up and talking like a madman. So slow me down from talking too much.
I think I heard him mention that he would be right back.
Oh, okay.
So, yeah, we'll just have to keep going.
Okay. Yeah, we got 45 of this thing. We can't let down.
Yeah, we can't wait. So, yeah, we'll just, I mean, it's recorded and you're giving us a lot of great information so he can look at it.
Okay. So this
number 9.
Let's see. Number 9 will be my number. Sorry, I'm rearranging my paper here.
Sorry.
Let's see.
Following best defines the notion of the significance level of a hypothesis test.
Okay. So in this one, I think what really messes, well, if the significant level is so when he and I got here, the first option, it's out of question. It has nothing to do with it. The second option, this is the value of P, or the meaning of value of P. So what we settled on was C, because the probability of committing a type 1 error is tightly related to the significance level. If you make the significance level too, correct me if I'm saying it the opposite way. If you make the significance level too high, or the confidence, if you make it too high, you will commit type 2 error. If you make it too low, you'll commit type 1 error.
I think that is right.
So I thought it was C when we got here, but you guys think it through. Yeah, and let me know. I know number 10 answer because it's a giveaway, but number 9, I kind of stopped on. Oh, wait, sorry, never mind. They kind of twisted the answer from here. So the probability of committing type 1 error was what I kind of settled on for number 9. But let me know if you see otherwise.
Okay.
So number 9, I'm thinking is 1. We are talking about the p-value over here. Yeah.
If it's number 1, then number 10, if you take a closer look at number 10, let's just go down real quick. Which of the following best define the notion of p-value? And that is C right there, the probability of observing a sample statistic more extreme than. Yes. So you see what I mean? So yeah. Once you get number 10 right, then number 10, then our answer is out of the question. So the first option is out of question here. The two option I think we have here, well, the 3 option would be the probability of type 1, the probability of rejecting HO, whether it's true or not, which I really don't understand that one. I don't know what it means. The probability of type 2 error. So these are our 3 options, since we already know number 10 to be the first option here.
Okay. Observing a sample statistic more extreme will actually obtain assuming the null hypothesis is true. Okay, so Uko, you think number 9 is the third one?
Yeah, type 1 error. That's what I think.
You think it's the first one?
No, I think the first one is out of board because we are looking at significance, not the p-value. So.
Okay.
So, what do you guys think of the probability of rejecting HO, whether it's true or not? I'm having a hard time understanding it, the answer itself. So you guys can see it from a fresh perspective. I don't really understand option number C, or option C, the probability of rejecting HO, whether it's true or not.
The way I see that is that you've got your null hypothesis, right? That is HO, and you're deciding if that is true or not. If it's not true, then you go over to your alternative hypothesis.
Oh, but okay, I guess then significant level.
Yeah.
Yeah, this one was kind of like once we got in. We can do we need to look at a book? Which one describe type 1 error and type 2? Was that chapter? Let's see.
Oh man, yeah.
Let me see. I'm gonna try to go to it real quick.
And they don't got good enough links here.
Let me go to my book. I don't know. I totally forgot to open a book. All right. Let's see.
That would be lesson 9 that it talks about a type 1 error.
Okay.
A type 1 error is when we reject a null hypothesis that is actually true.
No.
Yeah, the type 2 error is the opposite of that.
Okay.
It's when we should not have rejected the null.
So, thank you. You pondered. So the level of significance A.
Yeah. Go ahead.
No. I just noticed. So the hypothesis is true. The level of significance is the probability of getting the value of the test statistic. That's p-value. You say type 1 error is committed. Oh, wait. whenever we reject the true null hypothesis, we say and number one is even more confusing now that I'm thinking about. Should we ignore A and move forward and then come back?
Yeah, let's move on.
That way we won't kill our momentum.
Yeah.
Number 7.
No, 11.
Oh, sorry, number 11.
So suppose you create a 95% confidence interval for a mean and get 10 and 20. You've been told to report this by saying something like, we're 95% confidence that the true mean is between 10 and 20. Exactly what does this mean?
Second option. I don't.
95% of all 95% confidence intervals actually contain a true mean.
Because this question was on was it lesson 19 homework? I think something like this, or the first one.
Yeah.
The first 95% of the sample mean that's totally out. It's supposed to be we are 95% confident that the intervals actually but that's so the first option is out. 95% of the data are between, that's totally out of the question. There is chance, so he said we should not say chance. Remember from the note, we don't say there is 95% chance, because chance is probability.
Yeah.
So this one is the second one.
Yeah, that's what I'm thinking.
Okay. Yes.
Because the last one is out of question. 95% of the data is not between that. That's not what a confident interval means. And 95% of the sample means are between. That's definitely not. So yeah, that's how I said it on the second one. So use a fundamental to answer the next 3 questions. So I already worked this. If we want to move up, I can just read the answer for us to go. If you guys wanted to kind of work through it as a practice, that's totally fine as well. And then we can compare answers.
Okay.
Yeah. So the sample proportion is the p for value there, right? 0.30.
Here you go. Here you go.
Does that make sense?
So the p-value is what? I didn't get it clear.
No, they're asking what is the mean of the distribution of the sample proportion. It's already given there. P equals 0.30.
Yes.
Really? So the P is the sample proportion.
Let's run to the note real quick. I think that will be helpful. You see how we got it. Let me see samples. I'm trying to find a spot in the book.
I think that would be lesson 16, right? Or lesson 17?
It's somewhere around there, 16, 17.
Lesson 16 is where it talks about sample proportion.
Okay. All right, sample proportion. Oh, there it is. I see. Somewhere here, I promise. Okay. Let me see. So come down to 3.1, the tossing a coin example in lesson 16.
Okay.
And then scroll all the way down to, you may want to refresh your memory on the definition of unusual events.
Yeah.
And then if you drop low to that, it has mean and standard deviation. The sample proportion P is normally distributed if N is large. The true population mean of the random variable P is M of P hat equals P. You see that?
Yeah.
Yes.
Because that standard deviation right there, that formula, standard deviation of P equals, that's what we're going to use to get a standard deviation, which is the next question that is going to follow this.
Yeah. The standard deviation of distribution and sample proportions. Yeah, I see that. So 3.2.2 is where you were finding that.
Yeah.
In lesson 16. Standard deviation. So we gotta run the calculation.
Yeah, so the standard deviation in this case will be square root of 0.30 parenthesis open 1 minus 0.30 divided by 100.
Yeah. Getting my spreadsheet up.
Okay.
All right. This calculation here. P hat equals square root of 0.30 times minus divided by 100. Okay, I have .045 or 0.46.
Yep. Is that what you got to, Bartholomew?
Wait, give me some few seconds. Let me
Okay.
pull it out. So, so 0.004, right? What did you get?
0.046.
0.046. Oh.
Is that what you got?
Yeah. No, let me redo it again.
Okay. Wait. Let's see. 100 add up. Wait a second. Oh, guys. I just realized something. Let me double check the population again. So 100 adults. 100 adults. What was your standard deviation again? Because they changed the population size in a review. It was 200. Actually, it's always been 100.
The sample size was 100.
Was 100. Okay. And what did you get for your standard deviation?
0.046.
Okay, that's good. That's good.
Using the standard deviation of p hat.
Okay, that's perfect. There's another one I had, or I probably did it in homework. So I was looking at a different question. Never mind.
Okay. So let's move on. Number 14.
All right.
You said you got a 0.046?
Yeah.
Yep.
Wow, kind of. So P in the value of a year, there's 0.30. right?
What?
Yep.
The P is 0.30.
Yeah.
Yep.
How come
And
I got? I'm still getting 0.004.
all right. So have you checked your type of test?
Okay. Okay.
What type of test are you running on this, Uko?
Eh, Huh?
What type of test are you running on this?
This is a test of one proportion.
Okay, that's what I thought.
Okay.
Wait, actually, pause. It will be, but if we calculate the standard deviation, then it throws us back into Z test.
Okay.
So one sample Z test for proportion.
One sample, two, T. One sample Z test for proportion. Yeah, that's what I got. 0 standard deviation.
Because then the next step is we're gonna get the Z score for that, so we can calculate the probability. Let me share my screen with you guys real quick and show you what I did. Let me know if you can see my screen.
Yep.
So this formula in a book right here.
Yeah.
That's what I'm using here. So this is the N, so 100. This is the P, and this is the next question that will follow. But this is the standard deviation, and it's pretty much. Ooh, is that Bartholomew? But Bartholomew, are you there?
Yes.
Okay. It was just giving a heavy feedback from you. That's why. So so what I did here is just that formula, the square root of P times 1 minus P divided by N.
Mm-hmm.
And then I got my standard deviation from 0.46. And then the following question asks, what is the probability that your random sample of 100 adults will have a proportion less than 0.25? So that 0.25 is the given value. And the reason why the given value is important is if you come back here, it's right here. The given value is important because this is the value right here. And we're going to subtract the 0.30, which is the mean I was giving to us, or P minus, P divided by the standard deviation, so we can get the Z score. And then we'll take the Z score to the probability app and shade wherever appropriate side it is, so we can get a probability of, whatever they will ask in the next question. So does that make sense at all?
Yeah. So we're going to be getting a Z-score through the probability app.
Yeah.
And putting that.
We'll get a Z-score, take it to the probability app so we can get a probability of, because the next question to that, question number 14 is, what is the probability that your random sample of 100 adults will have a sample proportion? Sample proportion is P hat, right?
Yeah.
Less than 0.25. So
Okay. Yeah, I'm with you.
And you can even work it in the oh dang it, wrong file. This one. And you can even just work if you build that you can get that. Or I think we put it in here yesterday and it worked. Let me see. 0.25.
Make sure you change your type of test too.
So less than see about it. 125. No, that's sure what this is. But you know, so using that formula directly, I put a 0.25 down here, and what the z-score is calculating is, well, ignore this first part. It's d24 minus d23. So the given value, which is p hat, minus p divided by the standard deviation, which we already calculated up here. And that, and your z, when you calculate your z-score, let me know what you got.
Okay. Are you going by the standard deviation of the confidence interval?
Huh?
Our value is 0.25 minus the
the p they gave 0.30
0.25 minus 0.30
divided by 0.0
divided by 0.046. 0.25 minus 0.3. This divided by 0.046. I've got a z-score of minus 1.08. 7. And
if you round it down.
so now we need to go to the.
What did you get?
A z-score of minus 1.087.
That's weird. What am I doing wrong here? So 0.25 minus 0.30 divided by 0.046, right?
Yep.
That's weird. I don't know why mine is coming out. Mine is coming out with minus 1.091.
Minus 1.0.
And it's,
Right.
yeah, I'm trying to see this.
It sounds like you're rounding, maybe.
Oh, let me see.
Because if I were rounding this, I would round it up to.
I also got a minus 0.87. You got a right? Justin got minus 1.087, right?
No, 1 second. I probably did something here, but you guys are correct. If you guys both got it, you're correct. I'm like 0.0 something. I don't know if it'll make a big difference, but that's good. Let's take it to the probability app and see if there'll be a big difference in the probability that we get.
Okay.
Let's stick it to the
So what I've got on the for number 14 is 0.139.
Okay. That should be the answer. In the homework, the option they had was 0.138, 0.124, 0.876, and 0.862. The last two, just ignore it. So 0.13 now, 0.138 should be, but I don't know if they rounded up wrong there or not, but But yeah, if you guys had the same standard deviation, then that's good. We'll go with that.
Okay.
What was it? 0.139?
Yep, 0.139.
When I did it yesterday, I got the same thing. It kind of threw me off because I was like, how come they put 0.138 here when it's giving me 0.139? But I guess I don't know why they did that.
Okay, so
50.
0.139, we'll go with that.
Okay.
Man, this is a long quiz.
It's insane, man.
You might have to like take a break and come back later or something. All right, use the following information to answer the next 7 questions. Acupril is meant to control hypertension. In clinical trials of Acupril, 2142 subjects were divided into 2 groups. The 1563 subjects in the experimental group received Acupril. The 579 subjects in the control group received a placebo. Of the 1563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of the people who experience dizziness while taking Acupril. Let P2 be the true proportion of people who experience dizziness but do not take Acupril.
That's a lot of Cooper right there.
That's a lot of numbers they're throwing around.
Yeah. Let me see.
Create 95% confidence interval for P1 minus P2. And put the margin. Oh no. Margin of error, man. That's my vice. I can never get the margin of error right.
That's so good. All right. What test did I do here? Let's see. Okay, so this is 2 proportions. So we can go straight to the app and start plugging in the numbers.
So you think this is a 2 proportion test?
Yeah.
Okay.
So we'll go to the app. 61 is X1.
Okay.
And because if you look at it closer, they kind of try to throw you off. So the 579 students with 15 experiencing dizziness, those are the placebo group. That's the second group.
Yeah.
And then the 1563 subjects with 61 experiencing dizziness, that's the first group.
Yep.
So we plug it in and
so our N2 is
got another 5%. And we want that.
N1, sorry, is 1563.
Yeah.
Okay, and then the next one is 15 out of 579.
Yep.
We're looking for a 95% confidence interval.
Yeah.
With a P1. What's our type of test?
The type of test, 2 samples, Z test for proportion.
No, I mean the P1 less than P2.
Oh, not equal to. Let me see. The people who are speaking. They want to what? Let's see. What different 15 group.
Margin of error lower number.
So I'm trying to see what they want to determine here. I'm going over it again. So in order for the medicine to be effective, those that took the placebo score have to be lower than those that took the actual medication. Does that make sense?
Yeah.
So P1 should not be equal to P2. If P1 equals P2, the medicine is fake. It doesn't work. So I think the type of test is P1 is not equal to P2.
Yeah, that makes sense. I agree. So to answer question 15, the margin of error for this.
Okay.
I can never get this right.
So what I did was, I think I used your same formula, but where we were having the error last time was, so absolute value of the lower confidence interval.
Yeah.
Plus absolute value of the higher confidence interval. And then, so it's plus instead of minus, you add them up and then divide them by 2. That's what I try yesterday, but that margin of error thing drives me insane. Like, it's like, I don't know what this is. It's like some mysterious thing that, but that's what I did. And the margin of error that I came to was 0.016.
Yeah, that's what I'm getting too. Yeah.
So
margin of error.
And I'm not really sure about it. And that's kind of like, you know, the best guess that I can come up with. But if it doesn't work, we'll come back to it. And
I'm good with that. Yeah, that's my best guess on that. I always get the margin of error wrong. It makes me mad.
It's really annoying because I'm like, every other thing I'm getting right, but just this margin of error. So the lower end you guys got was minus 0.003, right? Or lower bound.
Oh, yes. Minus 0.003 on the lower bound, yes.
And upper bound was 0.029.
Yeah.
Is Bartholomew still on? Bartholomew, you there?
He's still here, but I don't know, his audio's out or something.
Oh, okay. Question number 18. Perform the hypothesis to see if the proportion of experimental subjects.
Can you hear me?
Yeah, we can hear you.
Okay. So I don't know why you guys can hear me. So the margin of error, what I got is 0.013.
How'd you get that? Like, what's your calculation if you can show?
The 2 confidence interval, I sum them up and divided by 2.
Did you get the absolute value or you just like sum them up directly?
Yeah, you got to make sure and do the absolute value because you're looking for how far apart the lower and upper bounds are.
Because it's okay, you got a half. Since we got 0.016 and you got 0.013, it's like half of, but.
Yeah. When you're doing the margin of error, what you're looking for is how far apart 2 numbers are. So if you have 2 positive confidence intervals, the lower bound and upper bound are positive, then what you're going to want to do is take the higher one and subtract it from the lower one. So you take the upper bound and subtract it from the lower bound. That's if they're 2 positive.
Okay.
If one's negative, like the lower bound, if that one's negative, you need the absolute value of it because you were trying to find out how far apart the 2 numbers are. And if you take just 0.00, if you take a negative and just add it, then you're not going to get different how far apart they are.
Okay.
That makes sense?
Yes.
Okay.
All right. So that brings us to 18, right?
Yeah. Form hypothesis test, see if the proportion of experimental groups who experience dizziness is different than the proportion of control group subjects who do. Use a level of significance. Okay, so I'm seeing a keyword in here is different than, so I'm thinking it's not equal to.
Yeah.
I think it's the first one.
The first one. So they want a null and alternative, right?
Yeah.
So if we pick one, then the alternative to HO will be less than P2. But is it two tail or one? Because I'm only asking that because the type of test we took is not equal to.
Yeah.
So if we take the first one, then our second option would be less, and then we'll have to change our type of test in the thingy in the sheet. That's what's confusing me a little.
Well, what I'm seeing out of that question, you see the keyword different
Mm-hmm.
right there. It's so it could be higher or less than, greater or less than.
Okay, so should we do not equal to, like this? What do you think about the second option?
That would be greater than. That's not including
Oh, sorry,
numbers that are less than.
I'm so sorry. Guess what I'm doing? I was looking at the review that I printed out and worked on because they switched them around. I'm so sorry. You're right. It's the first option. The first option there is the second option, on a review sheet. So instead of looking at a quiz, I'm looking at a paper in front of me. My bad.
You're killing me, Uko.
I'm sorry. I was like,
You're
wait a
making me
second.
second guess myself.
I'm sorry.
All right, so it's not equal to because we're looking for something that's different.
Yeah.
Okay.
And our test stats is.
So now we were trying to do a hypothesis test. Okay, the value of your test. So we need the test statistic.
Yeah. They're just asking for the Z right there, 1.458.
Oh, is that the Z?
Mm-hmm. That's the test.
Yes.
Okay, I've never known what the test statistic is. All right, I kind of know.
Mm-hmm. Yeah.
And then the p-value is 0.145.
Yep.
And these Excel sheets are a lifesaver.
Oh, you have no idea. It's just and this will help with the upcoming question. It goes really fast because once you get one right, since they are all related, you just keep picking the answer as you go. So it will be faster actually once we get to the latter questions, because it's kind of like this where you plug in your value in the right spot and you just copy and paste your answer. So so our p-value is 1.145. So 21 is asking.
Yep, 0.145 on number 20. So 21, we need to decide if there's sufficient evidence to reject or not reject the null hypothesis.
We're gonna fail to reject, right? Because it's 0.145 instead of 0.05.
Let's see if the p. It's what happens when the p-value is less than the level of significance. Don't we fail to reject?
If it's less, you reject. If it's high, you fail to reject.
Okay, so the p-value is higher than the level of significance.
Yeah, so we fail to reject.
That is the third one.
And I only remember that because the last time you told me, I remember I was struggling. I wrote it down on a paper and it's right in front of me. So whenever I get to a question like that, I go, p-value is less. Literally, I have this on a paper on my desk as I'm speaking.
That's perfect. Yeah, I'm going to do the exact same thing because it is kind of a weird way to say it.
Yeah. When p-value is high, we fail to reject. When p-value is low, we reject the null. So.
P-value is low, we reject the null. So we are not rejecting the null.
Yeah. So I guess the question, but it's a tricky question though, because the question will kind of add to the answers. Is there sufficient evidence to conclude that the proportion of people who experience dizziness while taking, and I'm only reading that because we have two correct answers. There is no, I fail to reject, and then yes, I fail to reject. You see the trick they're trying to play there?
Yeah. So what they're asking is, they want to know if there is if it's different, okay, if it works. So they're referring to the alternative hypothesis.
Oh, they are?
Yeah. So if you look there, the true proportion of people who experience dizziness while taking a Acupro they're talking about different. See the keyword different is in there?
Mm-hmm.
That's in reference to the not equal to alternative hypothesis.
Oh, see, this thing is tricky. So what do you suggest here as the answer?
Let me think about this for a second. So we are not rejecting the null, right?
Yeah. So we're failing to accept HA then?
I'm thinking of the fourth one.
The fourth one? No, Justin mentioned that because of the question, we're now looking at HA. We're going to ignore HO and look at HA. Does that make sense? Because they're asking. Yeah, you see, I didn't even see it until Justin mentioned it. That was a good catch. I didn't even, it went right over my head. So if they're doing that, then we're focusing on HA now. So it's either if it says sufficient to conclude that the true there's no one taking.
Different than the true proportion.
So
we are rejecting the alternative, so we are accepting the null. So, and they're referring to the alternative. So our it's going to be one of the no's.
So one of the no's. So
it's going to start with a no.
No, I failed to accept HA because we didn't accept HA.
Right. I think that's right. I think it's the first one.
Okay. Because I was thinking that one, or I failed to reject. But I guess since we're focusing on HA, that's why I was looking at the first option.
Yeah, to me, the first and the last one are saying the same thing.
Okay, so if they only accept this one, we can just switch it to that last one and see what happens.
Yeah, but we'll go with the first one since they're referring to the alternative, I guess.
Okay.
But to me, the first and last seem to be saying the same thing, but I might be misreading it. All right, so number 22.
Oh, and we are back to chi-square.
So we're talking about a survey of a bunch of random adults that are 18 and older. They asked, are you a morning person or night person? The hypothesis study is for the null, being a morning or evening person is independent of age. And the alternative is that being a morning or evening person is not independent of age.
So we're just gonna stick that in a chi-square and see what we come up with.
Yeah, so being a morning or evening person is independent of age. So they want to know if the older you are depends on if the older you are modifies or influences if you're a happy morning or night person. They'll calculate the test statistic for this hypothesis test, assuming the requirements for the test are satisfied. Okay, Uko, you're pretty good at this. What type of test are we using?
The chi-square.
This one is the chi-square.
Okay, cool.
Because we got rows and columns. That's another way to look at chi-square too. And we have like more than two groups. We got 18 through 29, 30 through 49, and 50 through 64. So.
All right, so 97, 177.
6, 7. I already did this one, but I want to see when we work through it so I can compare my answers. So.
Okay. I'm putting it into the chi-square. 31, 167. 190. Okay, so for the test statistic,
And
6.579.
yeah, that's what it says here. But on the this is really throwing me off. I actually wanted to email brother Bennett about it. The option that they have for answer on the homework, you know, the homework thing we work on, the closest answer to that was 6.580, but clearly the calculation here says 6.57. So I'm agreeing with you, but the option that they gave on the preparation thing was off. So I don't know if I should, because the only reason I'm talking about that is if we're using the review to prepare for the exam and the review is throwing us off, what happens when we get to the exam? So I don't know if I should bring it to his attention or not, but yeah, the test stats is 6.57. You're right, Just.
So does the individual preparation prepares for the group preparation?
That's what
questions.
Yeah, the questions are the same, but it just tweak them a little. Like option A will go to option C, and then option B will go to option A. That's what was messing me up, because it's the same question, but there are different numbers now. That makes sense.
Yeah. Okay.
So 6.579. That's good. And then our p-value right there, 0.087, right? Is that what you guys got?
Yeah, 0.087.
Okay.
That's what I got.
Okay. And then
for the p-value, yeah, 0.087.
Okay. And then should you reject HO or not? We'll fail to reject, right? So it'll be no. P-value is greater than 0.05. So the fourth option, right?
H0 being more hearing versus independent H. Are we rejecting the null because P is greater than the level of significance? So we remind me again, Uko, are we rejecting or not?
We'll fail to reject because P is higher than the level of significance. So 24 will be no, the p-value is greater.
No, yeah, I agree.
Yeah, p-value is greater than 0.05.
Yes.
Okay. And then the next 25 is kind of like the sentence to that, and this will be we have
I always get this wrong too.
It's this is section in this was lesson 18, right? Let me see if I can show it. This will help us word this better. Let me lesson 6.
So 25.
25.
We have insufficient evidence to say that being a morning or evening person is not independent of age.
That's what I'm thinking too. I wrote it. Where did it go? The note stated how to reject that. Is it 19? In 19, it should be in lesson 19. Sorry. Okay, lesson 19. So right below
I did a chapel.
So let me share my screen so you guys can see where I'm at. Share screen right there. Okay. Let me know if you can see my screen. Let me make this bigger.
Yeah, I see it.
Okay. So right about here, where is it? Where is it? Okay. Where on earth is it? It was somewhere around here. I just saw it.
The requirement, the 2.1.
Yeah. No. It's just how to word it. Okay. It should be there it is, right here. You see how they word it? If we reject the null hypothesis, we state there is sufficient evidence to suggest that, we restate the alternative hypothesis. But if we fail to reject the null hypothesis, we should replace the word sufficient with insufficient. So the only thing that we change in here, if we fail to reject, is insufficient.
Okay, so
and then we use the null hypothesis on it. No, the alternative hypothesis on it.
Okay, so we fail. There is insufficient evidence, right?
Yeah.
We have insufficient evidence to say that being a morning or evening person is not independent of age.
Yep, that's correct.
Yeah.
Okay.
So I just will review that because it will be helpful to remember on the exam. But that's where I caught it yesterday when I was going through it. And I was like, so the difference is just, insufficient, and then you use the alternative hypothesis. I didn't know. I used to focus on the hypothesis itself, but I was totally off. It's supposed to be the alternative. So, but cool.
Yeah.
That brings us to 26, right?
Yep.
Okay. This one wasn't that hard, I don't think.
All right. So a book noted that only 20% outperformed Dow Jones. Random sample of 200 investment graduated from one of the top 10 business firms. Period 50 of these outperformed. Let P be the true proportional investment manager clear. One of the top 10 business firms outperformed Dow Jones over a 5-year period. So we're looking at 200 investment managers. Graduated from one of the top. Were followed over a 5-year period. The 200 investment managers were followed over a 5-year period. 50 of those 200 did better than the average. So let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. So P would be 50.
Yep.
Okay. Create a 95% confidence interval. This is categorical, right?
Sorry. So P would be 50 divided by 200, which was give up 0.25.
Oh.
So it was to get little P, because we use point something to. Right, does that make sense?
Yeah. Is that in the book?
Yeah. Let's let me see here. We just did it? Should be 18. I'm not sure. 1 second. I don't know, 18 or 16.
It should be 18.
18, right?
Yeah.
Okay.
That's an 18.
18 is too proportionate.
We're talking about P hat in 18.
Yeah.
The P hat.
So if we're just looking for P, shouldn't it be sooner than that?
So the P, it should be the.
It should not 16.
No.
Okay.
proportion. The sampling distribution P has a mean of P.
Oh, sorry. Sorry, I'm throwing us off. I think P hat was what was going through my mind when I said that. I was wrong. Because P hat equals P. That's what was throwing me. Okay, so I'm back in lesson 16. It was like the first problem like we did. So ignore what I said.
Okay. Well, I see what you did there. You see in 2.1.1,
Yeah.
the formula there that is going x divided by n.
Yeah. That's what was throwing me off. And then in lesson 16, 3.2, well, not 3. Yeah, that's what was throwing me off. But I think P hat, in order for us to get P hat, it will be 0.25, but P is 50 because we're going to stick the 50 in that directly into the formula. So we can, yeah, so sorry.
Okay. So this is a categorical, right?
Yeah, I think let me go back to
So we're looking at a one proportion z-test.
Yeah. Let's see. I did.
Oh,
Yeah.
it's quantitative.
It is how do you say? I'm trying to word this the right way. So in it, they have a percent in there, so it's categorical. But this is where my Trudy and I forgot to asking here because some of these things overlap slightly. It is categorical, but the calculations here require this one sample z-test for proportion. So you're right, it is categorical. Because it says a recent book noted that only 20%, so they didn't write the percent in Word, they just said 20%, and categorical, once it's percent, we're back to categorical. That's why we're using categorical data analysis Excel sheet. Does that make sense?
I think so.
So, and we're using one sample for Z because the number we gave us should help us calculate that.
Yeah.
So one proportion. So X will be 50, N will be 100. I'm sorry, 200.
Yep, 200. Looking for 95% confidence level.
Yeah.
And our null hypothesis
is 0.20 because it's 20%. Does that make sense?
Yeah.
No, you said X will be what?
50.
Yeah, because they're saying that 20% of investment managers outperform. So that's our null. That equals 20%. But we need to decide if we are doing like less than, greater than, or not equal to.
You see. They said something in the question that
I'm thinking it's not equal to.
50 of these outperformed. So I don't know.
Outperformed the PB, the true proportion of investment manager.
Well, maybe we'll get more information in question 28, and we can actually figure out what type of test we're doing, if it's lower or upper or not equal to, what the alternative is. Because at this point, 26 and 27, those two questions, the lower and upper bounds don't change based on the null hypothesis.
Oh, I forgot I haven't put it. So lower and upper, you guys got 0.190 and 0.310, right?
Yep.
Sweet.
So on 28, suppose you had been in charge of designing the study, what sample size would be needed to construct a margin of error of 2% with 95% confidence?
I kind of got stuck on this one and made a guess on it. Margin of error. I wonder if we'll go back to the margin of error thingy.
Suppose you had been in charge. The sample size would be needed to construct a margin of error of 2% with 95% confidence.
So I am tempted. Here's what I'm tempted to do, and let me know if I'm kind of rolling off, okay?
Okay.
I'm tempted to get the margin of error. But let me share my screen. It will make sense when I show it, since I end up blabbering all over the place right here. Okay, let me know if you can see my screen.
Yep.
So what I want to do is, you see how we did a margin of error here?
Mm-hmm.
I want to use this formula. Let me come out. What was that? Just of one proportion. Yeah, right there. I want to come here and do this. So right now it's at 25. Let me see. If I put in percent, it's at 25%, right?
Mm-hmm.
So I want to goal seek. So, okay. So I will come here and do goal seek. Let me go to data. I want Excel to do the calculation instead of me. So goal seek. I want to set this cell to 0.2. By changing the sample size, right? No. Yeah, sample size.
Yeah, the sample size.
Population. By changing n, and then I hit OK and let it calculate. So 249.39 is how much we need to get this to 0.20. Wait, is it 20%? Yeah.
You had 0.25 there before you ran that goal seek, but
Let me hit control.
we're looking for 20%.
For 20%, right?
Yeah.
Okay, so when I run it, what it would do, it was change. Let me see. Equal. Fine. Let me change this to a number. That way we can kind of home number. Okay, so it's at 0.25, right? And we're trying to get two. Wait, we want lower than that, right? It should be I should have written 0.02. So it's at 0.25. So watch this, and we're trying to get. Oh, let me put it up here. 0.25. So right now we're at 0.25, and this is our old value. This will be our new value. So I will come here. Data. What is? We'll see. I want to change this to 0.02 because that's 2%, right?
Mm-hmm. That's 2%, yeah.
By changing, they want to know the population, right?
Mm-hmm.
So by changing this cell, then I hit OK, let it calculate. All right. Oh, dang it. Instead of hitting OK, I didn't. Okay, I'll do this again. You could hit OK to save. Okay, that's set to 0.02 by changing this cell. Okay. All right, hit OK. Okay, so that's what we get. We'll need 24.58.
Let me look at this. Suppose you have the sample size needed to construct a margin of error of 2%. Yeah, I think I understand where you got that. Margin of error of 2%.
And the only reason why I thought it would be okay is this right here is still the same. The null hypothesis, the 0.20, we're still using the same thing because I used the prior estimate of P equal 0.20 of 100%.
Yeah.
That's why this is like a total guess, you know, based on pattern. Like there's nothing from the book that is backing this. So please feel free to like, you know, challenge or like try to make sense of it. If it doesn't make sense, let's do something else.
Yeah, since we have isn't up to Tuesday before we can see this assignment, so we can still go over it and we still have more time to submit it later on. So
yeah, so let's move on. That's a good guess. We'll run with it. If we get it wrong, we'll work on it again throughout the week.
Okay.
So your answer is 2459, right?
No, 2458.18. What did it say we should round to? Are we rounding to one decimal place? Because the value that I have is, I'll read the entire thing, 2458.183022.
Well, we're talking about our sample size, and you can't do a sample size of like half a person.
So then 2458 then.
No, it should be 2459, I think.
You think
round up.
Wait, let me see. Because no, let me see. Let me round up. I would let Excel round it up. No, it's 2458 when I do. Can you guys see my screen?
Yeah. It's 2458.
Yeah, so you see that if I round up all the way, that's what it's coming to.
Well, we're talking about people here. You can't, if you round down, then you don't have enough.
No, it just round the direct watch. Oh, I guess so. What we have was 2458.18, right?
Yeah.
So, oh, I guess if we're rounding people, so in this case, you round up then?
Yeah, because you can't have half a person.
Oh, okay. So 245. I get what you're saying now. And then if it's up, we can always switch. But
I mean, while we're guessing.
Okay, 2459. Roger that.
Suppose you wish to see if there's evidence that graduates of one of the top 10 business programs performs better than other investment managers conducting hypothesis tests, use a level of significance of 0.05. Just following pairs of hypotheses is the most appropriate for addressing this question. Performs better. So we want our alternative is going to be greater than.
Wait, our alternative or our null?
Our alternative is going to be greater than. Our null is always equals.
Oh,
it can't be less than or greater than or not equal to. It's always equals.
Oh, thank you. That helps a lot because I struggle with that one too.
Yeah, the null is always equals. The alternative can be something else.
Okay.
So then it's either the second, third, or last, or second to last.
The second to last is what I was thinking because it's equal to and then greater than.
Yeah. So that's what I think. It's greater than.
Okay.
Okay. So number 30, what requirements must be met to ensure that p hat is normally distributed?
N times p is greater than or equal to 10. N times 1 minus p is greater than or equal to 10. What do you guys think?
Yep, I agree. Yep, that's what I was going for.
The value for your test statistic. What the heck? How did we get a value for that one?
Well, we're still working off of the performance of managers. So that information from above question 26.
Okay. So then our the test stats that I have here, is this when we change it to 2%, or when we change the population size, or
Yeah, good question.
yeah, that kind of threw me. If it's when we change the population size, then the z-score that I have is minus 22.269. That's the test statistic. If it's back when we just plug in a number from fresh, I'm pretty sure it's different than that.
Yeah, with our n being 200.
Yeah.
Oh man.
N being 200, we have the test is 1.768.
Okay, in question 20, okay, let's look at the information areas as a change in something. Okay, so like for example, in question 28, that's not an information area, that's a question.
Oh, so we should fall back on the
think-
original question, right?
I think so.
Okay.
The next information is above 29, so we need to use a level of significance of 0.05,
Okay.
which is fine.
Okay. So then if that's the case, then our test statistic will be 1.768.
Yeah.
But Bartholomew, are you following?
He actually dropped off.
Oh, geez. 1.7, and then our p-value is 0.039, right?
No.
Oh.
I'm saying 0.077.
Sorry. What was our test again?
1.768.
Oh, no. The type of test. I think I changed my type of test. That's what's throwing me off. Is it less than, equal to, or not equal to?
Oh, that was my bad. I didn't change it. So now I've got the p-value at 0.039.
Right. So that's greater than, right? And is that type of test correct? Like, I forgot what the question.
Yeah, because we determined the alternative hypothesis on number 29.
Okay.
So yeah, we're doing for greater than.
Okay, sweet.
Oh man, this is long.
So that's
12 more questions. 12 more.
Okay.
Number 33, is there sufficient evidence to conclude that graduates from the top 10 perform better than other investment managers?
So,
so they're referring to the alternative hypothesis again.
Yeah, so the p-value is off here. Oh, the p-value is lower here. So, so fail to accept? Fail to accept HA then?
So we fail to accept the null, right?
Wait, no. Fail to reject the null or fail to accept the HA. Does that make sense? No. Actually, sorry. Pause, rewind. The p-value is low. On a regular story, we reject the null hypothesis because the p-value is low. But when they put this question in it, then it kind of throws me off. But I know fundamentally, because this is low, we'll reject the null hypothesis.
Yes, we reject the null hypothesis. So that means that we do think that they are greater. So we accept the alternative. So our answer should be one of the yeses.
Yeah. So that would be the second to the last one.
You think it's that one? I accept HA. Yeah.
Because there's sufficient evidence. So out of that,
again, I think the first and second to last are saying the same thing, but whatever.
Yeah. So yes, I reject HO, or yes, I accept HA.
Yep, I think it's HA, just because we're referring to the alternative.
Okay.
But I think they're both saying the same thing.
Okay, we'll just swap them around if the first one is off.
Yeah. Okay, number 34. Only 11 more.
Oh man, almost there.
Okay.
Oh, this blue thing, we got to stick it in again.
Oh, great.
There's a file that we have to.
Awesome. Okay, computer software is commonly used to translate this as part of this. There's translation for quality of the translation can vary. Oh, we've heard this one before.
Yeah, this is from the quantitative like forever ago.
Yeah. Yeah, this is.
Yeah.
To compare the pairs ability. Yeah. Okay. We need to input the lower and upper bound.
Mm-hmm. So the one that I used on this one was one sample t-test.
Okay.
One sample t-test for means, because we're looking at a mean here, right? He wants to use that
yeah, well, we've only got one sample.
Okay.
So yeah, we're at one sample. It's quantitative. Yeah, I agree. One sample t-test.
Okay. I'll already put it in, but once you're done with your sheet, I will read my answer so you can compare it.
All right. Oh crap! Did I do that? Okay, so we're doing a 95 confidence interval.
Shoot.
A null.
So they know I put in the mean score that he put there. 2.95. I don't know if I did it right, but
Transactions mean score of 0.295. And was that a greater than?
Oh, I just put not equal to because he want to see if it differs.
Okay. Yeah, that's a good point. Not equal to. Okay, so what I'm seeing for the lower bound is 0.282.
Yeah, that's what I got too.
And then the upper bound is 0.293.
Yeah, and in the 1 second. Okay. Yeah, so that's what I calculated too. And my t-score was minus 2.803, and my difference something was the degree of freedom was 99.
Yeah, that's what I have too.
Okay. Lower bound.
So calculate degrees of freedom. The test statistic and the p-value for a test of H0 equals. Well, that gives us the answer. Or it tells us what our null hypothesis is right there in question 36.
All right. Oh, 1 second. Let me. 36. Oh yeah, 0.29. Oh yes. Whew, we did it right then.
Good job. That was all you, man. You did it. So input the degrees of freedom. So that'd be 99.
Yeah, you want to put your 0.000 there. I don't know if they will duck you if you done, but
I don't know.
I like to put in the round to 3 decimal places.
Yeah, that's true.
To make sure that.
So test statistics is minus 2803.
You see how it's going fast here? Like once you put your data in, it's just copy paste. And...
Yeah, I'm okay with that. We can just keep doing that. Input the p-value. Rounded to 3 decimal places. So I've got 0.006.
That's what I got too.
Sweet. 39. Based on the results of this test, what would you conclude? Okay, p-value is 0.06. That is less than the level of significance. So
we have insufficient evidence to say that the true mean is equal to. Wait a second. Let's revisit the So he wants to use his data to see if it differs from the mean blue score of another leading translation. And then null here would be that we have insufficient evidence to say that the true mean is different than, right? No?
Let's see. We're looking for not equal to. So we are we rejecting the null?
Yeah, we are rejecting the null because it's the p-value is less.
Okay. So that means that it is not equal to.
So the third option is what's coming to my mind because we have insufficient evidence to say that the true me is different, because different kind of sounds like differs. Since the original question said this doctor, he wants to use this data to see his mean blue score, if his mean blue score differs from the mean blue score of another. Does that make sense? That's what I thought, it's different, but I think it's good to take time and go through it again. We have sufficient evidence to say that. So the first option would mean we are oh, actually, I take that back. The first option is saying that we reject the null, right? Because if it's different, then it does differ. And then the second option would say we fail to reject, because if there's insufficient, then we fail to reject. And the fourth option can be because he's not trying to see if it's equal to, he's trying to see if it's different, if it differs. So the fourth option is out. Does that make sense?
Yeah.
So right now we got three options. Insufficient means you fail to reject. So both insufficient, I'm just like deducting, just canceling out which one can that be. That's how I ended up with the first one, but think through it, take your time and think through it.
I've tried to think through it, and every time I get it wrong. Like, to me, we are rejecting the null. So that, to me, says that we have sufficient evidence to say that it is not equal to.
It's not, so it's different then?
Different than, yeah, I would say that it's the first one.
Okay, that's what I'm thinking too. So we'll go with that. If it's off, then we'll try
to
get it.
Yeah, we'll have to come back if it's wrong.
Oh, and then we got to do this height one too, which I think is it is a pair sample, by the way.
Number 40 is?
Yeah, number 40 will be a pair sample.
All right. Let's open up the data. Yep, it is paired for sure. Wake up in the morning, get to test the state of the heights of the children. Measure values. This sounds familiar. I think we've had this before.
Yeah, I think it was on one of the exam or something.
Yeah. You want to determine if the children are taller in the morning and in the evening, define the differences as AM height minus PM height. So AM minus PM. Construct a 95% confidence interval. All right, I'm going to put in the data here.
Okay.
All right, we are double significance of 0.05. The null hypothesis.
So we'll put 0.05 to the null hypothesis, right? I don't, because the null hypothesis right now that I have is 0. I already put my data in, but I just have it as 0, and I don't know what to put there. So right below the confidence interval, I don't know what to put in. I don't know if I should keep it at 0 or change it. I'm a bit lost there.
Well, our type of test, I believe, is greater than.
Okay, so I'll switch that.
The null hypothesis, they want to see if kids are taller. So the null hypothesis is that they're not. I guess it'd be 0.
0, okay.
I think, yeah, I think so.
Okay, I struggle with that one because like the previous one, when they give, the percentages, it's easy for me to see it, but when they don't give it, then I'm like,
yeah, no kidding, me too. So yeah, I think that our null hypothesis is 0 and confidence interval 95 and type of test is greater than. So with that, I've got lower bound of 8.728.
Yep, that's what I got. Upper bound of 10.455, right?
Yep. Upper bound. Yeah, 10.455. Okay, 42, input the test statistics for this test. That would be 282.446.
Yeah.
Yeah. Input the degrees of freedom. That'd be 40.
Yep.
44, input the p-value.
I got zeros.
Yeah, me too. Based on your results of this test, is there enough evidence to suggest that children are taller in the morning than in the evening? Our p-value is less, so we are rejecting the null, right?
Yep.
So again, they're referring to the alternative. So we are rejecting the null. It means we're accepting the alternative. So it's going to be yes, because we rejected the null.
So that'll be the first one. Wait.
Third one.
Oh, the third one. Okay.
Yes, because we rejected the null. So we did reject the null.
Okay. So we still have number 9, but other than that, we're good. So we'll come to number 9.
Number 9.
Which one of the following best defines the notion of the significant level of hypothesis test? I'm really leaning towards type 1 because the first option is out of these 3 options. And I think you mentioned earlier, the 4th option is the opposite of the first. So it's just the 3rd option that is throwing me for a loop.
Yeah, I don't know. Tell you what, I'm gonna submit for us. Let you know.
This thing is so long.
I know it is. Okay, so we got an 83%.
Holy cow. What did we get wrong?
Oh, man. All right, so number 33 is wrong.
Number 33.
Number 28 is wrong. I'm actually not too surprised there.
33, 28.
Number 21 is wrong. We're getting all those ones wrong.
Is it the ones that we were guessing on?
Not so far. It's the ones that start with no or yes.
Oh, so it's just the way we word it. Okay. So 21, 28.
Circular reasoning.
Okay.
So number 10 was wrong.
Number 10. How about number 9?
Number 9 was right with the type 1 error.
Sweet.
Yeah, so good job on that. That you just called that one. Number 5 was wrong.
Number 5. Ooh.
We called that one a one sample t-test.
One sample. So let me see. What was the question? Let me see. The question was number 5. Number 5. One sample t-test. Student project compared. Let me go back to when my buddy and I did it. Question number 5 right there. Oh boy, you guys are gonna throw stone. I mean, that was wait, one sample. Yeah, number 5, a student. Yeah, one sample t-test. I wonder how we got that wrong.
Yeah, number 5 was not the one sample t-test.
Huh.
Yeah, I wish they gave us unlimited chances on this.
So number 5. So we got 5, 10, 21, 28, and 33 wrong.
Oh no, we also got 3 and 2 wrong.
What the heck? Now I'm doubting myself now. I'm gonna give my buddy trash when I see him next time. We got number 3 and then number 1. Wait, what was number? Let me see. Number 3 question was what they number 3. What did you put?
For 3, I put test of 1 proportion.
Oh, it should be 2 proportion.
Oh, should it?
Yeah, that was what you can just mark that. I'm sorry.
That's all right.
And once we get done with this next adjustment, I will submit mine real quick to see where we're at. If I get 95, I mean, this thing is already taking 2 hours.
I know, it's taking so long.
If I get a 95. So yeah, so we corrected 3. Which other one was wrong?
So 3 and 2 was wrong, and I did test of 2 proportions on 2.
2, oh no, 2 was chi-square.
Oh, was it? Yeah,
because there we got 2 countries, and then we got 2 different other things that they're measuring. So we have more than that. It's categorical, but we have more variable in it. We have more variable than 2. So chi-square.
Okay. So 2 is chi-squared. 3 is test of 2 proportions.
Yep.
All right. Oh, 5. What's your other guess for 5?
5. Let's see. Let me go to 5. I gotta read it. Make sure I'm getting the right question. Question 5 is a student project. A student. Okay. Let me go through this again because I was almost certain that I had that right, but let me see. That's the person participate. Oh, please, guys, don't throw stone at me. It's a pair sample because the same kids that unlock one lock will be the same kid that will unlock the other lock. So it's a pair sample. Oh, you can be a goofball sometimes. So it is a pair sample.
Okay, paired sample t-test. All right.
I can't believe that.
That's all right. Not a big deal. Number 10.
Number 10.
Let's take a look at that.
Okay.
So find best defines the notion of the p-value of a hypothesis test. It's got to be the probability of a type 2 error if it's not a type 1.
What? No. So the value of p determine whether or not we reject HO, right?
Yes, when compared to the level of significance.
Wait, so what was your first option that you had? Let me check.
For number 10, I did a type 1 error.
Oh, no. It's supposed to be the probability of observing a sample statistics more extreme than they want. That's literally like the definition of p-value right there. Okay,
so I might have misheard that when we did it.
I'm sorry. That was probably when I was jabbering and running my mouth here and there. So yeah, it is the probability of observing a test score more than
so when the hypothesis is true. Okay.
So the third option. And then number 21, right?
Yep.
Number 21, let's go there. 21, okay. Ooh, okay. So is there sufficient evidence? So right here, we chose the first one because we thought the last one was filtered because there is sufficient evidence that the true proportion of people who experience Disney while taking Acupay is different than the true proportion of us. So we failed to reject, and we took the first option because we thought it was the alternative that they were asking, right?
Man, I don't remember.
Yeah. So right here, the question said, what's the information thing? Okay. So it is a medication test. So the control group have to have a different value compared to those that actually took the medication. Because if they're equal, then the medication, it just doesn't work. It's just the same thing. So it has to be different. So if the p-value is higher, then we will fail to reject that it is different. In other words, that the medication work. So what was that question at? If we got 18 right, which is P is equal to P1 is equal to P2 and H is P1 is not equal to P2, then there is sufficient evidence to conclude that the true proportion of people who experience Disney while taking Acupil, so P1 is different than the true proportion of people who experience Disney while taking Acupil. So we fail to reject HHO. Oh, actually, sorry. Yes, we fail to reject HO. So the fourth option.
Yes, failed to reject
HO.
HO. Okay.
Okay. So number 28 now, right?
Yes.
Number 28. Oh, that was our guess. So I will drop this to 8 instead of 9, and then I will give you a test run, okay?
Okay.
So and you can, or if I get it right, I will read it, and then that brings us to 33. 33. Okay. Okay, so our p-value is less, so is there sufficient to conclude that the graduates from the top 10 business, what was our null and alternative here? Let's see, okay. Our null was p equal 2, so equal HO was p was greater than, so then the question here would be, is there sufficient evidence to conclude that graduates from the top 10 business program perform better than, so yes, we rejected HO.
Which one are you looking at?
33.
Oh, did you skip 28?
Oh wait, I thought we did 28. Let me go to 28. So with 28, that was when we were guessing. You know, when I did our goal seek thing, and we got 24.5818, yada yada yada, and we're rounding. So we did 25.9 because we couldn't do like a half person. So I'm dropping it back to 58, 24.58 to see if, you know, it's still a guess because I'm not sure if that calculation is like anywhere in the box. So I'm gonna put it to 24.58 as a guess and see if we get it right.
Okay.
And then 33 was yes, I rejected HO.
Yes, I rejected HO. Okay.
Because p-value was less. And that's it, right?
Let's see. So P is less than the level of significance. That means we rejected it.
Okay.
So yeah.
Okay. I will go ahead and read my answer. If I'm gonna submit, so that when I'm done, I can just read it. So question 2, chi-square. Question 3, test of two proportions. Question 4, test of one proportion.
Do you mean 5?
Sorry. Anyway, it's how it was conducted.
Because we got 4 right.
Test of
one proportion.
And what was 4?
4 is test of one proportion.
Okay, so test. Moving on, question 5, pair samples t-test. Question 6, pair samples t-confidence interval. Question 7, confidence interval for two proportions.
Yep.
Question 8, one sample t-confidence interval. Question 9, the probability of type 1 error. Question 10, the probability of observing a sample statistical extreme. 11 was 95 of all 95 confidence intervals, so second option. Number 12 was 0.30. 13 was 0.046. 14.138.
0.139.
Oh, 0.139, shoot. 139. Let's see. 15.016, 16 minus 0.003, 17.029, 18, first option, 19, 1.458,
yep,
0.145,
yep,
21, yes, I failed to reject HO. 22, 6.579.
Yeah.
23, 0.87. 24, no, p-value is greater than 0.5. 25, last option. 26.190. 27.310. 28, 24.58. 29, second to the last option. 30, first option. 31, 1.768. 32, 0.039. 33, yes, I rejected HO. 34.282. 35.293. 36, 99. 37 minus 2.803. 38.006. 39, first option. 40, 8.728. 41, 10.455. 42, 22.446. 43, 40. 44, zeros. And 45, yes, because we reject the no.
That's right.
All right, go to submit. All right, let's see. Oh, dang it. 95.35. I will go through and see which one we got wrong. Let me go start.
Hey, that's pretty darn good. 95%.
Yeah. Let's see. So question
number 2.
Number two is chi-square, so that's good.
Okay, number 3.
Number 3 is test of two proportion. We got that right.
Okay, number 5.
Let's see. Number 5 was pair samples t-test. That was totally my mistake from earlier. So that's good. So pair sample is the answer.
Okay. Number 10.
Number 10, let me go. Number 10, the probability of observing. So the third option was correct.
Okay. Number 21.
21. Yeah. Number 21, I got it wrong.
Okay, so it's not that one. So it's not yes, I failed to reject HO.
Oh, why didn't I see it? It's 145. So no, I failed to reject HO. Dang it, dang it, dang it, dang it. That should have been the
21?
answer. Yeah, on 21, it should be no, I failed to reject HO because the p-value is higher. You see, like it's a double negative in the option that I chose, the fourth option. I'm saying yes, and then I'm saying I failed to reject. See, is there sufficient evidence? Yes, but I failed to reject. Instead of no, I failed to reject because
okay.
You see what they're doing. So they want you to answer the question up here first, and then state your decision on it. So it should be no, I failed to reject, the last option.
All right.
Okay.
So that's probably the only one you got wrong, huh?
No, now there's one more down here. What was the other one? 28, right?
Yeah.
28, I got wrong.
Okay.
So,
not too surprised there, to be honest.
Yeah. So that's off. Other than that, 33 is the first option. So we got that right.
All right, good.
So far, 28 and 21. And I think the reason we got 21 wrong was because it should be the last option. That's what I say, right? And
yep.
and 28, I won't sweat on 28. I will just probably talk to my buddy about it. I'm meeting with him on Tuesday before I take the test. If you guys are done by then, that's fine. But once I meet with him and we go over it, I will probably just let you guys know what to do there in case it comes on the exam. But if you're already done by Tuesday, that's fine. I'll just send an email out anyways. If